Good evening. The sky at night is now 55 years old, and in celebration, we're going to take you on a journey to the edge of the known universe, and perhaps even beyond, assuming, of course, that there is a beyond. With me are the two Chris's, Chris Lintott and Chris North. Chris, something about the speed of light itself.
Absolutely, because if we're going to explore this vast universe of ours, we better go as fast as we possibly can. And we know, thanks to Einstein, that the fastest thing in the universe is light itself. And light travels at about 186,000 miles every second, which incidentally, I like to think it's about a foot every billionth of a second, so a foot per nanosecond, which makes it slightly more comprehensible, I think. But it's this speed that we have to attain if we're going to get anywhere in the universe.
Light reaches us from the sun in about 8.6 minutes, and from the moon in just over a second. That means that once we look beyond the Earth and the moon, our view of the universe is bound to be very out of date.
Absolutely, and that can cause some problems.
Yes, I mean, logistically, when operating space probes and Mars rovers elsewhere in the solar system, they have a problem that the signal from Earth that we might want to send to Mars, to a rover, takes somewhere between 5 and 20 minutes to get to Mars, depending on where it is in its orbit. So the response from the rover, which might say, yes, I've moved that meter you wanted me to move, also takes between 5 and 20 minutes to get back to Earth. So if someone sends an instruction for the Opportunity rover, for example, to drive just the edge of that cliff, then they can send that instruction, but it might be more than half an hour before they find out whether it did it or whether it ran off the edge of the cliff or anything. And logistically, that can cause problems. So you can't drive the Mars rovers with a joystick in real time, as fun as that would be.
Yeah. The nearest star beyond the sun is over 4 light years away.
Well, absolutely, Patrick, but we should explore the rest of the solar system first, don't you think?
Yes, we should indeed. I've got the torch here, I've turned it on with a beam of light. Now, that beam of light is going to go on through the solar system and beyond. And Pete and Paul have been in my garden, and they're going to go along with this beam of light.
So Patrick sent out a beam of light from Farthings, and now that's heading out through space at the amazing speed of 186,000 miles every second.
It is, and we are going to chart its journey through the known universe. So let's first of all start off from here on the planet Earth.
OK.
We're going to be intergalactic lollipop men. There's the Earth.
And as it's the 55th anniversary, let's go out to a position which is 55 light hours out. So what we're going to do is use Patrick's garden to actually introduce a sense of scale.
So this garden gets used for an awful lot. I don't think it's ever used to represent the universe before.
No, it hasn't. Well, let's mark the position of 55 light hours here, and that indicates the position in the solar system where light travelling at 186,000 miles per second would have reached after 55 hours.
Let's put in the rest of the solar system. I have here Pluto. Why don't you be Pluto? Can you count?
OK, yep.
And I'll be the planet Saturn. The planet Saturn is a mere 8 inches away from the Earth. In actual terms, it's about 1.5 light hours. Now, you've got the planet Pluto there.
I have, and Pluto would sit about a metre away from the Earth, so that's the sort of scale out to Pluto. But, of course, that isn't the end of it, is there? There's more stuff beyond that.
There's a little man-made object. Do you remember Voyager 1? Got a little prop here for it. Voyager 1.
Have you drawn Voyager 1?
I have drawn the lack of anything else. Drawn Voyager 1. Voyager 1 launched in the late 70s, went out into space and surveyed the planets. That, even travelling at the speed it is little more than a third of the distance away.
OK, so a third of the distance from the Earth to our 55 light hour marker.
That's right, the furthest man-made object. And just look at that, Pete.
That's
We've
incredible.
got a small bit of solar system there, the furthest man-made object. But look how much distance there is still to go.
So that is actually the edge of the solar system which we've got there, where Voyager is. But of course, to go out further, so we're going out into the stars, we have to look at scales which are much, much larger than this.
We do. We have to up from light hours to light years.
Our light beam is now travelling beyond 55 light hours, and we're going to 55 light years. Let's find out what's out there.
We've got out now to 55 light years, so let's pause to see what we've found on the way.
Well, we've already passed about 200 of the naked eye stars, the ones we could see from Earth without a telescope or binoculars. And those are the stars that are cheating, really, that appear bright in our sky because they're not intrinsically brilliant, they're not particularly luminous, but they're close. And so they appear bright. We've left them behind us. Interestingly, we've passed a couple of thousand stars now, and 80 of those we now know have planets. So we may well have passed other worlds like the Earth and other solar systems like our own. Given that this is out here at 55 light years, we're just receiving the first transmission of the sky at night. If there is life on any of those thousands of stars that we've passed, they'll be enjoying some of your programmes.
You'll now know all about us.
Absolutely, absolutely. I'm sure they're entering your competitions and writing in and sending in their observations as we speak.
But I think one of the fascinating things about going so far out is that we've gone 55 light years. We've only passed a couple of thousand stars. That sounds like a lot, but if you look at the distance between the stars, it's actually immense compared to the size of the stars themselves. So we scaled the sun down to 1 millimetre across. That's about the size of a pinhead. And we put it in the middle of London, just outside the Houses of Parliament, or the top of Big Ben or something. The next nearest star on that scale would be about where the M25 is, 10, 25 miles away, that kind of distance. They're incredibly far apart, given their size. So what this tells us is that, in terms of stars, the space is pretty empty. There's a bit of gas and dust there as well.
We're leaving 55 light years behind and travelling out to 5,500 light years. There's lots to see on this journey, so back out to Pete and Paul.
Here we have the Earth 55 light years. All the little nearby stars go in this little bit. So we have Sirius.
That's the brightest star in the night sky.
That's right, 8.5 light years, so that's plonk that there.
Okay.
Vega.
Okay.
Lovely star, blue star in Summer Triangle. We plonk that there. And in the constellation of Orion, of course, Betelgeuse.
The armpit of the central one, its name means.
Oh, lovely. You've just joined it now. We're going to put that around about the 700 light year mark.
Okay.
So around about there. Okay.
And I have a representation for the Pleiades open cluster, that beautiful cluster known as the Seven Sisters.
Yes.
And that's about 420 light years out. So that would be about there.
About there?
Yeah, okay. So you realise that 5,500 light years is an incredibly long way away from the Earth, but you can still see individual stars out that far. And if we go right to the very boundary, we find a star which is known as Mu Cephei, or Herschel's garnet star.
Oh, a lovely deep red star.
It's a very deep red star, and that sits roughly in this position here.
Isn't that remarkable? From the Earth out to 5,500 light years, you can see with the naked eye this one little star.
That's amazing,
isn't
isn't
it?
it?
Boundary. That is remarkable.
Our light beam is now going to go much further on a journey from 5,500 light years to 5.5 million. There's lots to see on the way, so back to our intergalactic travellers in the garden.
We have a model here of our own galaxy.
The Sky at Night plate. This is a wonderful model of the galaxy. It's made by Chris North, actually.
He's done a very good job here.
Yep.
We've got the core of the galaxy represented here, and then we've got the spiral arms coming off like so.
And we have little companions around the galactic core. We have globular clusters.
That's right. These are little sort of condensations of stars in a halo around our galaxy.
All gravitationally bound. And M13 in Hercules is a good example. So they just sort of hover around the galactic core like this.
They do, but the globular cluster, I mean, M13 is a good one you've mentioned there. That's an amazing object. You can see that from the UK through a telescope. It's a beautiful thing to look at. It contains anywhere up to an estimated 1 million stars in a sphere which is 145 light years across. So next to our own galaxy, we have two companion galaxies. In fact, there are a lot of companion galaxies, but these are two of the most prominent.
These are the large and small Magellanic Clouds.
That's right, which are visible from the southern hemisphere.
Yeah, we
can sort of represent them in this rough position down here. So let's put the galaxy plate down here.
And the Magellanic Clouds.
And the two Magellanic Clouds.
Let's go see what's in the neighbourhood.
Let's go meet the neighbours.
And look at this.
Another plate.
Another plate. This is the Andromeda Galaxy, so we're sort of 2.5 million light years from Earth. And this galaxy is much larger than ours, isn't it?
It is. And this is quite an easy thing to see in the night sky if you've got clear skies. Actually, if we look at that, if you have that galaxy face on like that, the Andromeda Galaxy is tilted over a bit, so you see it as an elongated smudge.
We have these little satellite galaxies. We've got NGC 205 and M32 that go accompany it.
And if you look at those through a telescope, a small telescope will actually show those two satellite galaxies quite close.
You need a wide field to see it. So what do we have here?
A little bit further. This is about just over 3 million light years away. So this is the Triangulum Spiral, Messier 33. This is a lovely galaxy, although it's very difficult to see with the naked eye. Where we had that one slightly tilted over, this one is face on to us. So we see it like that, and because of that, its light is spread out over a big area of sky.
It is. It's 3 degrees, which is 6 lunar diameters. So it
So
is.
it's actually in the sky. It's not too far from the Andromeda Galaxy. It's in the neighbouring constellation of Triangulum.
And this is about 3 million light years away from Earth.
It is, and so all these galaxies here, and including some others, are what are known as the local group. They're all a group of galaxies which are all gravitationally bound together, a family of galaxies, if you like.
Family of galaxies. This is all our little local family and neighbourhood, isn't it?
That's right, it's the local galactic neighbourhood. But those galaxies are all moving through space together, and to find out where they're going, we're going to have to go a little bit further than our 5.5 million light-year marker.
Our journey continues to the edges of the known universe.
Well, travelling with my beam, starting from my garden in Southsea in Sussex, we've travelled 5.5 million light years, and that's quite a distance. Well, Chris, where next?
Everything we've talked about, after all, isn't static, it's in motion. The Earth is going around the Sun is going around the centre of the Milky Way galaxy, and the Milky Way itself is moving to create those cosmic collisions, those interactions with Andromeda and M33, the Triangulum galaxy that we talk about. But from out here, all this way out, we can see the local group itself is moving, and it's being pulled by the gravitational attraction of our nearby city of galaxies, what we call the Virgo cluster, a vast collection of many, many galaxies, most of them more massive than our own.
I mean, one of the interesting things can happen when you get these enormous clusters of galaxies that they themselves start colliding, and you get clusters reaching clusters. And if you go even further out, if instead of talking about hundreds of millions of light years, we talk about billions of light years, so thousands of millions of light years, then you really start to see the honeycomb structure. And you see that galaxies are arranged not just in walls, but in huge sort of arrangement of
Filaments.
Filaments, yeah.
Filaments. Leaving huge voids.
We should finish this tale of where we're moving, because we got as far as the local group heading towards the Virgo cluster. So you might want to know, well, what's pulling Virgo and the Virgo cluster?
Yes.
And we give a name to the thing. We call it the Great Attractor.
Great Attractor.
Which sounds like a terrible sci-fi movie. But the reason we don't know much about the Great Attractor is that it's in a place that's awkward for us to see from Earth. If you remember, if you go back, we made that decision to come out of the plane of our galaxy, to go up above the Milky Way.
Did.
But from within the plane, the Great Attractor's hidden in what we call rather wonderfully the zone of avoidance, the part of the sky that we can't really look into the distance in because it's blocked by the nearby galaxy. And so something down there, probably a very large cluster or a place where a couple of these filaments cross, is this great attractor, this cluster to end all clusters that's attracting even something as large as Virgo.
It'd be very easy to get lost on this kind of scale, so we should probably take a brief pause and look at something we're going to be doing in the second of our special episodes to celebrate the 55th anniversary of the Sky at Night. It's called a Moor Marathon, things you can actually see in the night sky. And it's something you came up with in the 1960s, Patrick, and we've managed to find some old Sky at Night footage.
Long, long ago.
Good evening. So, our first Sky at Night went out just over 5 years ago, and we have been told we can have more programmes, which is just as well, because 1962 is going to be a busy year. We've had a Russian and now an American, John Glenn, in space, and the young President of America, John F. Kennedy, says he wants to land a man on the surface of the moon. The Russians want to do the same and get there first. It's really rather like a race. There are, of course, a great many things to observe in the night sky, and people are frequently asking me, Patrick, what shall I look at? And it's for this reason I've come up with something new, a Moor Marathon, full of objects observable in the night sky throughout April, and I've chosen 55. Seems like a good symmetrical number to me. Now don't worry if you don't have a telescope. A great many of these objects are visible with the naked eye, although you may need to find a dark site. So, number one should be my old favourite object, the moon. This is my moon globe here, and visible is the missing section, the side normally turned away from us. The Russians sent their Lunik 3 probe here to take a look, finally putting paid to that story that the moon is made of green cheese. For my April Moor Marathon, I've included a great many constellations, such as Cassiopeia, number 4, and the Pleiades at number 14 should be visible with the naked eye, but once again, by 2012, you might need to visit a dark site. Then we reach our binocular objects. I recommend a good pair of binoculars. These once belonged to a German U-boat commander. I picked those up during my time in the RAF. And this takes us to our telescope objects. And so, let's go outside to my telescopes. Now, this is my wonderful brass 3-inch telescope I received as a boy, and the rings of Saturn look quite superb in it. So, at number 39 in the Moore Marathon, the rings of Saturn. Mars, as you know, a great favourite of mine, and in at 49, Syrtis Major on Mars. There is still some debate as to whether or not this is vegetation, and we won't know for sure until a spacecraft is sent there, and that won't be for quite some time yet. So, back to mapping the moon. Someone from the National Aeronautic and Space Administration has been on the telephone. As I was saying, they want to land a man on the moon and need some advice as to where to go. I shall recommend the Mare Tranquillitatis. I wonder.
Patrick has set the challenge of seeing 55 objects in the April sky. If you go to our website at bbc.co.uk/skyatnight, you can find out how you can take part. And next month, we'll report how everyone got on. Now to return to the last stage of our journey on Patrick's beam of light. It's taken us 5.5 billion light years to get to this part of the universe. But out here we pass nebulae and galaxies which at first glance seem rather familiar. There's a boundary to how far we can go, how far we can see. It's simply the great unknown.
There is a limit, and we don't think there's nothing beyond there. In fact, we're pretty sure there is stuff beyond there. There simply hasn't been enough time for the light to travel from those most distant regions to the Earth for us to see it. And so you'd think that that limit was 13.7 billion light years away, because the universe is 13.7 billion years old. But in fact, in that time, the universe has been expanding. And so the observable universe, the stuff we can see, is actually 45 billion light years across.
And in that volume, we've got probably 100 billion galaxies with 100 billion stars. But all of that is probably only a tiny fraction of the whole universe. And out in the great unknown, beyond the limits of the observable universe, our theories tell us that we think the universe could be infinite. And if that's true, there'll be infinitely many galaxies, between them infinitely many stars, and around them infinitely many planets. With on them infinitely many Patrick Moores celebrating the 55th anniversary of the Sky at Night.
I wonder. We're looking out into the great unknown.
So what do you think's out beyond the great unknown?
I have no idea. It's a fascinating thought. Shall we go and explore it?
I think that's a good idea.
Do you think there'll be a pub?
There might be an infinite number of pubs.
You're all round anyway.
Well, that's always the case, isn't it?
So, the great unknown. That part of the universe that's so distant that what exists there is not actually visible to us. So I've always had a great fascination with what may be discovered there. And, most reassuringly, by Jove, it's me. Hello again, Patrick.
Hello, Patrick. What a surprise to find you here.
Yes, it's most reassuring. I couldn't resist having a look. How have the 55th anniversary celebrations of the Sky at Night been going?
Very well, Patrick. We're celebrating our 55th anniversary of the Sky at Night. And next month we're going to do a Moore Marathon.
Yes, I remember thinking of a Moore Marathon in 1962, and I wish everyone great success with it in 2012. And as for the great unknown, what can exist there? A void? A vacuum? Perhaps an infinity of universes? Well, one thing's for sure.
We just don't know.
No, we certainly don't. And so from all of us here, until next time,
Good night.